percentage word problems, where basically you're going to set up an equation like we've been doing, but there's going to be some type of a percent involved. All right, now the first type here is very basic, just translation involving percentages. So find the number the number 34.3 is what percent of 98. So when you're doing a problem like this, 34.3 is to the left of the word is. So is translates to equals. So 34.3 equals what percent. That means we don't know. I use p when the variable known as percent of in these problems translates to multiplication and 98. Alright, so 34.3 equals p times 98. We're solving for p, so we're going to divide both sides by 98 to get the p by itself. Okay, so hopefully you're starting to pick up on this idea of whatever's being done to the variable we're solving for, we have to undo. So if it's being multiplied by 98, we need to divide by 98. So that's going to get rid of the 98s, and we have p equals, and then go to your calculator here. Okay, 34.3. We're going to divide that by 98, and we get 0.35. Now, this is why I use p instead of x or n. When I use p, it reminds me when I solve for this variable, I need to move that decimal point 2 places to the right to write it as a percent. So that's 35%. Okay, now if it's any other position, if it's not a percent that we're solving for, if it's what we call the amount or the base being beside what's the word of, then we don't have to move the decimal point. Alright, now another option, this is the way a lot of people were taught to do these percent problems, and that's what we call the is of method. Alright, if you know this method, you want to use this method, it's completely fine, but is over of equals p over 100 is the way a lot of people approach this problem. And the way this works is the two most important things here are of and p, and then we can find is by process of elimination. But the way it works is you look for the word percent, the percent symbol, and then whatever precedes that is the percentage, the number that goes here. Well, when that's what, then that means we're just going to leave p. Alright, and then you look for of, there's of, the number that's to the right of it, 98, is what we put there. Alright, and then if there's any other numbers left over, 34.3, that goes where the is goes. Now, in this problem, it happens to be 34.3 is right beside is, so we could just go straight to there if we wanted. But the reason why I highlight these two is because it is very difficult in a percent problem to hide percent and of. If you say the word percent, almost immediately, every time you say of, just about every time. But you can get by without saying the word is. Okay, you can eliminate is, you could say was, were, or you can just get by without saying any form of the verb is. But it's just really difficult to not say either one of these. Okay, so that's why I always highlight these first, and then by process of elimination figure out what number goes where the is variable is. Alright, 98 times p, now we just cross multiply to solve this. 98 times p equals 34.3 times 100. Alright, and then remember, we multiply by a power of 10. We just move the decimal by how many zeros. So 1, 2 places would give me 3430, and then 98 times p equals that. And now I'm going to divide both sides by 98. Again, just like we did before to get the p by itself. Alright, and then again, if I go to the calculator this time and do that, I'm going to get 3430 divided by 98 equals 35 without the decimal point. Okay. If you use the is over of method, it's got the 100 that's used to move the decimal point around built into this method, so you never have to move decimal points around. So a lot of people prefer this method just because they don't ever have to worry about, when do I move the decimal? Do I have to do it on this problem? Do I not have to? If you use this method, you'll never have to worry about your decimal point. You just take the numbers as they show up in the problem. Alright, and then it gets into more applied problems. So this circle graph right here shows the uses of corn production. Alright, animal feed, food, other, ethanol, exports. And we want to find out what percent of corn is used for food, seed, other. That's the 12%. Or exports. Alright, that's 19%. Alright, and all we have to do is just add these together. So 12 plus 19 is 31%. So there's our answer. Alright, now we start to get into these increase-decrease problems. Now read them carefully. This thing increased the price of this $1.45 cola by 10%. We want to find the increase, alright, the amount it increased by, and then the new price after the increase. Alright, to find the increase, we multiply 1.45 times 10%, but as a decimal. So we're changing 10% back to a decimal. That's 0.10, or just 0.1. And then we're going to multiply this. Oops, wrong one. So 1.45 times 0.1. Remember, when we multiply by powers of 10, it just moves the decimal point the other way. Alright, or by powers of 10 smaller than 1. So there's one decimal point, that's one decimal place after the 0, that's going to move it back one place. So 0.145 is the increase. And what do we do to that? We add that to the old price. Alright, so 595. Alright, and then we would round this because it was money, and so we round money to the nearest cent. So that's the new price. Okay, so that's how you do this problem. The increase is how much it goes up by, and that 10% is based on the original amount, and then the new price is adding your increase to your original price. Original plus the increase is your new price. Alright, so that's what you're using to do this problem. Alright, this meal costs $42.60 including tax, but not the tip. Okay, find the cost if we use a 15% tip added to the cost of the meal. Now I'm going to show you how to do this two ways. One is the way that most of you know how to do it, is multiply your cost times the tip amount, so 15%, and that'll give you how much you should tip. So if you want to tip 15%, you multiply by 0.15. $6.39 is how much you should tip. Alright, so that's the tip amount. Alright, but then we're adding it to the cost. So find the total cost after we add that. So we add that to the $42.60, and we get $48.99. Alright, and again, that just came from $42.60 plus $6.39. Okay, that's where that number's coming from. Now that's one way you can do it, but if they don't ask for this step, like intermediately, like what's the tip going to be added, if they just want to go from amount before the tip to the amount after the tip, then all you have to do is, instead of multiplying by just 0.15, you multiply by 1.15, and the 1 takes care of multiplying by here, and then this is the tip, this is the 0.15. Alright, this is the 1, so 1.15. That's why I'm multiplying by this number, and it takes me straight to the amount after the tip. So that's an optional second step that you could do if you wanted to. So 42.60 times 1.15 will also take you straight to the amount. Alright, so either way you want to do it will get you there. It's just this takes you straight to the price afterwards, where you don't have to compute the tip in the middle there. Alright, percent increase, there's a formula for percent increase and percent decrease, but I'm going to give you both. Percent increase is equal to the larger amount minus the smaller amount divided by, if you increase, that means you're originally smaller, so we'll always divide by the original amount, so in this case that'll be the smaller amount. And then percent decrease, the numerator is the same, meaning we always divide the larger minus the smaller, but this time we're going to divide by the larger, because if it decreased, it was originally larger. But in both cases, what you're basically doing here in reality, what you're actually doing is equal to the change in the amount divided by the original amount. Alright, so that's what's going on when you do these percent increase decrease problems. So if I go back up to the original here, and it says the number of fraud complaints rose from this to this, alright, that means this is smaller, obviously, and this is the larger. So this is what I subtract from this. So for this one I'm going to do 430,000 minus the smaller 260,000 all over, this is percent increase, so the original amount was the smaller 260,000. Alright, now they're all thousands, so I could just as easily shrink this down to 430 over 260 divided by 260. Alright, and even then they still end in zeros. As long as they end in zeros, you can subtract, get rid of the zeros. So 43 minus 26 is 17, and then 17 is over 26. So this is 17 divided by 26 equals 65.38 blah blah blah. I'm going to round that to 0.654, and then this is percent. Oops, 654, and this is percent, so I'm going to write it as 65.4% was the increase. Alright, now I do want to show you, so you'll see I just got rid of, there's 3 zeros, 3 zeros, 3 zeros, so I just got rid of them. But I want you to see that even if we didn't get rid of them, I still would have got the same thing here. So 430,000 minus 260,000 divided by 260 divided by 260,000, it still gives me that same decimal. Okay, so it doesn't matter if you use the original numbers that you set up or if you take out the zeros. If you're not comfortable taking out the zeros, then don't take out the zeros, just use the originals. But as long as you understand that these are thousands, these are thousands, this is thousands, I can get rid of the thousands, and now they still all three end in the zeros, so I got it all the way down to this. Alright, find the original price of a pair of shoes if the sale price is $14 after a 75% discount. Now when you're doing problems like this, when you're finding the original amount, so you know what it is after a discount or after a markup or after a raise, what you have to do here is let X equal what you're looking for, the original amount. And then think about what they did here. They took the original amount and then they subtracted off 75% of the original amount. And then after that discount, they're getting $14. Alright. Now, when you do this subtraction, you got to also remember there's a 1 right here. It's 1x minus 0.75. So you got 1, you're subtracting off 0.75, what's left? 0.25. So another way you can think of this, if you want to skip this step every time, is if there was a 75% discount, that means you're still left to pay 25% of the original price. So if 25% of, remember we said with percent of means times, so 25% times the original price is 14. So you can think of it that way. We want to know the original price. There was a 75% discount. That means we're left to pay 25% of the original. Okay. Now, if you multiply this by 0.75, you're not going to get the original. If you divide this by 0.75, you're not going to get back to the original. Okay. You've got to do it this way to be able to get back. It's got to be this number plus this number as a percent equals 1 for you to have it set up properly. Alright, divide by 0.25 on both sides to get rid of the number in front of x. Alright, and you get 14 divided by 0.25 is 56. Alright, so the original price was 56 bucks. Alright, so very similar. Last year's salary is 2% after, find last year's salary if after a pay raise we get this much this year. So again, this time we're going to let X be last year's salary. And you think about like what we've been doing. X is the unknown value. Well, we don't know last year's salary. So X is last year's salary. How do you get a new salary? You take your last year's salary and you add the raise. Our raise is 2%, but again, a percent cannot stand alone. What's your raise based on? It's based on your last year's salary. So 0.02x equals 35,700. So last year's salary plus 2% more than I made last year, added to that gives me my new salary. Okay, just like we did before. 1 plus 0.02 is 1.02 x equals 35,700. Alright, and now I'm going to divide by 1.02 to get x by itself. Alright, so I make 35,700 this year. That was after a raise, so it's got to be that I made less last year, and I did 35,000. Alright, now look at the difference between these. What was the number in front of x after I simplified? It was bigger than 1 when I had a raise. The last problem, a discount, the number in front of x is less than 1. Okay, and this will always be the case when you're doing problems like this. Alright, how much pure acid? Pure acid means 100% acid. Should be mixed with 4 gallons of 30% acid in order to get an 80% acid solution. Alright, so look again, what are we being asked to find? How much pure acid? So again, we're going to let x equal the amount of pure acid. Mixed with means we're adding something usually. 4 gallons of we said means multiply 30% acid solution, so that's 0.30 in order to get equals an 80% acid solution. So 0.8 of what? 80% of the total. What's the total? X plus the 4 gallons. Okay, so our equation is 100% times X. So X, 100% as a decimal is 1, so 1X plus 4 times 0.3. If you need to do it on a calculator, do it on a calculator, but 4 times 0.3 is 1.2 equals 0.8 times X plus 4. There's your setup. Alright, 1X is the same as just X, so I'm going to write that as that. And then on the right side I need to distribute this through. So I get a 0.8X and then a 0.8 times 4. Alright, again, if you need to use your calculator, use your calculator. But 0.8 times 4 is 3.2. 1 decimal place. 8 times 4 is 32. 1 decimal place means start from the right and put that decimal place one place back. So that's why we're getting 3.2 there. Alright, now I got variables and constants. Variables and constants, so it doesn't matter which way I take what, but I'm going to subtract 0.8x from both sides. Now it's gone on the right, but a lot of people will just say negative 0.8x because they're forgetting that there's this 1 right here. Okay, if you need to put the 1 there, put it there. But 1 minus 0.8 is 0.2x plus 1.2 equals what's left over here is 3.2. Alright, we've moved our x's here, we're going to move our constants here. So I'm going to subtract 1.2. Gone over here, and I've got 0.2x equals 2.0, or just 2. Alright, and then finally, last step, divide both sides by 0.2. Alright, and then I get x is equal to 10. Alright, 10 what? Gallons. So 10 gallons pure acid. Alright, now a way you can check on this, you got to understand what you've just done. 10 gallons of pure acid means we've got 10 gallons of acid so far. Okay. Now, this is 4 gallons, 30% solution, so that means that 4 times 0.3 that we did right here to get the 1.2, that's acid also. So 1.2 more gallons out of that 10 is 11.2 gallons. That's how many gallons of acid we have so far. Now, it was 10 gallons plus 4 gallons is 14 gallons. So if we divide 11.2 by 14, we get 80%. And that's what we want, an 80% acid solution. So take this, add 4 times 0.3 to it, and then divide by the two numbers total, 4 plus 10. So again, that's what we did to check it. 11.2 divided by 14 means I've got an 80% solution. Alright, another mixture problem. These all work kind of similar. Alright, but we got Coffee Company, they want a new flavor. Alright, they've got $7 a pound coffee, they've got $3 a pound coffee, and they want to make $5 a pound coffee. Alright, so again, how many pounds of coffee worth $7? So X is going to be our $7 per pound coffee. And again, we're adding to it 10 pounds of coffee worth $3 a pound. So 10 times $3 to get, there's our equals, a mixture worth $5 a pound. So the mixture, meaning X, there's times the $7 a pound, added to $10 a pound. So X is the amount of $7 coffee. 10 is the amount of $3 coffee. How much coffee do we have together? We have X plus 10. So X plus 10 times $5 a pound. Alright, so there's your setup. Instead of writing X times 7, I'm going to write it 7X plus 10 times 3 is 30 equals 5 times X plus 10. I'm just putting the number in front of the parentheses. Alright, distribute on the right side to get rid of the parentheses. 5X plus 50. Alright, and now we've got an equation we've been solving for 3 or 4 modules or sections now. Subtract the variables to get them all on one side. 7x minus 5x is 2x plus 30. Subtract 30 from both sides. So 2x is equal to 20. That means I need divide by 2, divide by 2. 20 divided by 2 is 10 pounds of the $7 coffee. Okay, X is the number of pounds of $7 pound coffee. We need 10 pounds of that. Alright, now if you notice that was the same amount as this, and also note that 7 plus 3 is 10 divided by 2 is 5. So that number that we want is right in the middle, so we need the same amount of each for that particular problem. But we'll look at one in a little bit that's got different amounts. Alright, a student at the university makes his money by buying and selling used cars. Alright, so this guy bought a car for that and sold it for a $15 profit, or 15% profit. How much did he pay for the car? Alright, so again, this is very similar to what we were looking at before. We know what he sold it for. Okay, we know he made a profit. What was the original amount? So X is what he paid. So if we take X and we add to X 15% of what he bought it for, then we get what he sold it for, because he made that profit. So it has a very similar look to the raise problem. And remember, raise went up, so we're adding 15% or 2% in that problem, 15% here. Alright, profit means it went up. Alright, 1x plus 0.15x is 1.15x, and that's what is equal to 4623. Alright, this is being multiplied, so we divide it away, and we get x is equal to, go to your calculator, 4623 divided by 1.15 is 4,020 is what he paid for the car. Alright, and then this is another one I was telling you about. It's a mixture problem where the percentages are not are the number in the middle, or the number of the mixture, the percent in the mixture is not right in the middle of these two numbers. It's closer to this number than it is this number. Alright, but you're going to do the same approach for all of these. Look what you're being asked. How much of the 40% copper? So X is the amount of the 40% copper. Okay, mixed with, again, we're going to add 500 ounces of times 90% copper, 0.90, in order to get, there's our in order to get, equals a mixture that's 50% copper. So 50%, and again, 0.4 is our percentage here, so 0.4 times X, because that's what we don't know. Alright, plus this equals 0.5, and then the total, X and 500. Alright, it's always the percent that's copper times the amount, that number of ounces or pounds or whatever the unit of measure is. So once again, I'm going to move this around. I'm going to put the x on the right, so this is 0.4x plus, multiply these out together, use your calculator if you need to, 500 times 0.9 is 450, and that gives us this thing, 0.5 times x plus 500. Now, once you've got it set up, this is just exactly like what we've been doing. We're no longer concerned with the fact that it's a word problem for the next little bit. We're just doing our algebra that we've been doing the last couple of days. So 0.4x plus 450 equals, distribute, I get a 0.5x plus 0.5 times 500 is 250. Alright, and then group your x's together. Gone on that side, I'm just left with 450. 0.5 minus 0.4 is 0.1x plus 250. Alright, subtract 250 from both sides. Equals 0.1x. And then over here, 450 minus 250 is 200. Alright, so 0.1x equals 200. We won't want 0.1x, we just want 1. So we divide by the number in front of that, and we get x is equal to 2,000 ounces. Alright, so there is another typical mixture problem. I take the number of ounces of this 40% copper, I mix it with these 500 ounces, 90% copper, and I get something that's 50%. Alright, now when you do a problem like this, one way you can kind of eyeball check without knowing 100% for sure is, since 40 is closer to 50 than 90 is, we need more of the 40% than we do with the 90%, and we're getting that here. Okay, so that's one way to know, but again, the way you actually check it is you take the amount you got for your answer times the 0.4, times 0.4, add to that the 500 times the 0.9, alright, that's what you get here, 1250, and you divide that by the total amount of ounces that we have here. So we got 2,000 for x, 500 for the other. Add those together, divide, and we get 0.5, and that's what we wanted here in our mixture. Okay, that's how you can check that.